Scott, just to jog our memory, we said if you give me more than one mass, the only tweak, I could still go winner minus loser, it was equals M all A. Oh, and then often, just for giggles, we would ask you to find the tension in the string. We looked at examples where we had one mass hanging over a cliff. We said those were a little easier. This one was a bit more interesting because it had friction. And then I left off saying we can even handle more than 3 masses right to here. I'm not going to give you one like this on a test, maybe as a bonus, but not as an actual question. It's too long. And honestly, you can handle 5 masses. You can handle 12 masses. But we'll do one, and I'll assign one from the homework just so you've practiced it, just to let you know that we can generalize this. It says, find the acceleration and find the tension in both chords. Okay. Eric, how do you think I'm going to start out? What might this be a good job for? And what I'm going to do is I'm going to label everything. I'll write an equation for everything to find the acceleration of everything. And then I'll go look at individual masses to find some individual forces. I always start on the left and work my way to the right. You don't have to, but if you want your answer key to look like mine, if you're looking at one of my solution keys, I'll start on the left. So what are the forces acting on the 1 kilogram mass? Get the obvious one. I totally agree. Is there more than one mass in this question? I'm going to call it then M1G, not just MG. What else? First of all, is it sitting on a surface? Is this mass sitting on a surface? No. So is there a normal force? No. There's a rope. Yep. Hey, wait a minute, folks, look up. Is there more than one rope in this question? Say yeah. I'm going to call this, I don't know, tension A. I'll call the other rope tension B. You could call it tension L for left and tension R for right. Tension 1, tension 2. I don't care, but those all work. Good. You found where we are now? Excellent. You can turn your page. Yeah, good. That's it for mass 1. Sophie, what are the forces acting on mass 2? Get the obvious one. I totally agree. What else? Normal force number 2 is what I would have done next because we're not sinking to the ground. We're not, right? What else? Tension? Friction? What did you say? Which one? Friction or tension? Tension? There's 2. I think this rope, tension A, is slowing it down. But I think this rope, tension B, is speeding it up. What else? Is there friction? Because this is on a surface. Is there a coefficient to friction? Is there a mu? Then do they want me to include friction? Yes. Which way? Which way is this mass sliding? Well, how big is mass 1? How big is mass 3? If this is sliding at all, which way is this mass sliding? It's got to be to the heavier. This one's got to be pulling down. Yes? So it may be that when I solve this, I get a negative acceleration. What that's actually going to tell me is friction is so big right here that everything is just dangling and stuck. So I'm going to say friction is pointing that way, and I'll call it friction force number 2 to go with mass number 2. Because I think it's sliding to the right. Ella, what about the 8 kilogram mass? What are the forces acting on it? Get the obvious one. Good. I'll call it M3G. What else? Tension B. There you go. Okay. Who's winning? I think M3G. I think this whole system is accelerating in that direction. So now I'm going to walk along the rope. It's going to be kind of a long path, but any force that once it gets to this side is pointing down, I'll call it winner plus. Any force that once it gets to this side is pointing up, I'll call it loser minus. So, winner. What about this tension B? Winner or loser? Everybody? What do you think? Loser. What about this tension B? Winner plus. What about this tension A? Loser minus. What about friction force number 2? Loser minus. What about this tension A? Follow it, follow it, follow it. Because it's tempting to say, well, it's pointing up. This one pointing up was a loser. But if you follow it, follow it, follow it. I think when it gets to this side, I think it's pointing down. I think it's winner plus. And this M1G, although you might be tempted to say it's pointing down, so it's a winner, I think if you follow it when it gets to this side, it would end up pointing up. I think it's a loser minus. That equals M all A. Oh, this one's kind of nice. We lose twice the tension. Your tension B's cancel? Yeah, because you got tension B minus tension B. Do tension A's cancel? Yeah, so I can go like that, like that, like that. Oh, what's this question asking me to find? Scott's theorem. I could even go like this. Alrighty. A equals M3. 1? No, 8. Was it 8? Yep. G, 9.8 minus, what am I going to write for friction? Well, first my brain would say Aiden friction is what times what? What's mu? I don't know. What's mu? I've scrolled down. What's mu? 0.25? I don't know the normal force. Oh, look. I don't know the force is the same size as a normal force. Which one? Can you tell me what M2 and G are? And then minus M1G all divided by M1 plus M2 plus M3. Now, on a test, I would probably never do it quite this fast. But for what it's worth, 2 lines, if we really wanted to. That's probably how I do it in my homework. Worth practicing typing this in. Is this a fraction? Yeah, definitely brackets around the top and around the bottom. Unless you have the fancy fraction button. There's a bit of a built-in error check. The fastest the acceleration could possibly be is 9.8 if I cut the rope above mass 3. So I know I'm going to get less than 9.8. In fact, I think I'm going to get a fairly small acceleration here. Yeah, 2.59? No? I see 1 nod, but yeah, 2 nods. Yeah, okay. And it's an acceleration, meters per second squared. By the way, I had somebody ask me the other day, Mr. Duick, acceleration is a vector. It has direction. How come you're not asking us also for the direction? Up and right and down, because as soon as I have more than one mass, there's more than one direction. And so we're just finding the magnitude of the acceleration and then saying, figure it out from there. So what did I assign last day that you could start working on? I had crossed out number 8. I'm going to say you can try number 8. So 1, 3, 5, 6, 7. Add number 8, a 3-mass problem. You might even be able to do number 8 right on the sheet if you write smallish and label a picture. 9, 10, 12 is nasty. And 7, I think we also put a star next to. I'll talk about both of those tomorrow. Okay? We're nearly done.